Alright, so sixth graders, we're going to talk about divisibility of numbers today. Meaning that, can a number go into another number evenly without a remainder? Alright, so in other words, 5 can go into 10 2 times without a remainder. Okay? 10 divided by 5 is 2 without a remainder. And so there are certain numbers that you can follow rules to know if that number is divisible evenly by the other number. So for example, the rule for 2 is simple. It's all even numbers are divisible by 2. You can always cut an even number in half, right? It's divisible by 2. So if the last digit of the number is either 2, 0, 2, 4, 6, or 8, then you know that it's divisible by 2. No matter what the number is. If it doesn't end in an even number, if the last digit is not an even number, then it's not divisible by 2 without a remainder. Okay, so for example, 13 is not divisible by 2 because it ends in a 3. And the 3 is not an even number. Do you understand what we're talking about here? Raiden?
And I was writing down the thing, which you mean by 3 or 9?
Well, I'm going to explain that next because that's the next part that I'm going to talk about. Okay? The rule for 3, actually the rule for 3 or 9 is kind of the same rule, it just applies to the different numbers differently. The rule for 3 is that if the sum of the digits can be divided by 3, then the number is divisible by 3. Okay? So if you look at this number right here, 189. 189, when you add the digits together, 1 plus 8 plus 9, Josh, what does that equal? Follow along, please. 1 plus 8 plus 9 is 18. And since 18 is divisible by 3 without a remainder, then this number, 189, is also divisible by 3 without a remainder. Okay?
That's what you're trying to get to.
Raise your hand, Rita. And the rule applies to the number 9 also. In other words, if the sum of the digits are divisible by 9, then the number is divisible by 9. So is 189 divisible by 9? Jack?
No. Wait, yeah.
Why?
Because 6 is
What goes into 9? Are you, look up here please, okay? I don't think you're really focused on the lesson. So what is the sum of the digits again, Peter? 18. Is that divisible by 9? Yes, so then the number 189 is divisible by 9. Okay? So this number 189 is divisible by 3 and by 9. Okay? Do you have a question, Matt?
Mm-hmm.
What is it?
So it's the big number, and then you just add all of them.
You add all these digits together.
And then exactly, where did we get the 3 from when you divided it?
We're trying to decide if the number is divisible by 3.
Okay, and then so 9 goes into 18.
Right. And so then we can say that 189 is divisible by 3 and by 9. Well, what about 343? Is that divisible by 3? It ends in a 3. Does that mean it's divisible by 3? What is the sum of the digits? What is the sum of the digits of 343? Raiden?
10.
10. Is 10 divisible by 3? No. So then this number is not divisible by 3. Is it divisible by 9, Megan? Why? Yeah, 9 can't go into 10 evenly without a remainder, right? So then this number is not divisible by 9 either. In fact, if a number is not divisible by 3, it's not going to be divisible by 9. Okay? Yes?
How is this supposed to help us how is this supposed to help us when we're in
When we're doing math,
yeah.
what we're going to be doing coming up is working with fractions and reducing fractions. And so you're going to have to look at numbers and figure out, are they divisible by 2 or by 3 or by 5? So we can reduce the fraction from, for example, 5/10 to 1/2. So we're going to have to learn these rules and be able to look at numbers and see if they're divisible by other numbers. How about the rule for 5? That one's pretty simple, because you can all count by 5s. Every multiple of 5 ends in either a 5 or a 0. So if the number ends in a 0 or a 5, then we know it's divisible by 5. Okay? The one for 4 is a little different. The rule for 4 is to check to see if the last 2 digits in the number are divisible by 4. Okay? So let me show you an example of that. Let's say we were starting with this number. Is this number divisible by 4? Tyler?
Yes.
Yes, because... Yeah, because 16 is a multiple of 4. So this whole number is divisible by 4. Okay? You need to check the last 2 digits to see if it's divisible by 4. Okay? How about this one? Oops. What would we do if you couldn't just check it by looking at it? What would you actually do? How could you check this number? Johnny?
Well, it's not divisible by 4.
It's not divisible by 4, but how could you figure it out without dividing the whole thing by 4? Nate?
So you know how 16, goes into 4 times, right? And 4 can go into 16.
Yeah, 4 can go into 16, so
Yeah.
this one's
So
divisible by
then
4.
I did this. I did 16 plus 16, which is 32. And 32 which is 64. And 16 plus 64, which is 96.
Okay.
Which is the closest. And I was like, nope, it doesn't go in.
Right, that's true. Yep.
Because then on 9 is 4, and see if that could be whatever, 96.
Yep.
94, but it would be 92.
Yep.
That's what
Or we can just do this real quick.
whatever.
We can just do this and see 14. Nope, that doesn't work. Because that will be a remainder of 2. So you might just have to check using division. Check to see if it's divisible by 4. Okay? But you only need to check the last 2 digits. Because the rule says if the last 2 digits are divisible by 4, then the number is divisible by 4. Raiden?
How would that help you in the 5?
In dividing, we're answering the question, is this number divisible by 4?
Why is it not under dividing?
How about this number? No, that's Is that divisible by 4?
No, wait.
No.
No? So what would half of it be? So if we, what we have to do with the hundreds is you have to check it with the last 3 digits. Okay, if there's zeros, then you might have to use the next digit. Okay? Yes?
Then it's yes. Okay, right.
So 500 divided by 4 would be, and then, whoops, 10. Okay? So if there is another digit, you might have to use that. Okay? Otherwise, yes. Otherwise you can just use the other 2 digits. Okay? For the rule for 8, the rule for 8 uses the last 3 digits. So the rules for 4 and 8 are similar. Okay? The rule for 8 is to use the last 3 digits instead of the last 2 digits. Okay? And the rule for 6, you also need the rule for 6. So if you want to, you could write the rule for 8 next to the rule for 4 because those are similar. And then the rule for 6. The rule for 6 is if the number is divisible by 2 and by 3, then the number is divisible by 6. So, odd numbers cannot be divisible by 6 because they're not divisible by 2. So only even numbers can be divisible by 6. And then what would you check? If it's an even number and the sum of the digits are divisible by 3. Okay? So look at this one, 246. This ends in a 6, but is it divisible by 6?
Yes. It is.
Yeah. It's 41.
It is actually, it is 41.
Yep, because 2 plus 4 is 6, plus 6 is 12, and 12 is divisible by 3. So rather than saying it's 41, you could say, yes, because the sum of the digits is 12, and 12 is divisible by 3. Okay? Is this one 252? Is that divisible by 6? It's not? What's 2 plus 5?
Oh!
2 plus 5 is 7. Plus 2 is 9. And is 9 divisible by 3?
Yeah.
Yeah, so then this number is divisible by 6. It's an even number and it's divisible by 3. Okay? Any questions on that? So what you're going to do is practice identifying those factors, they're called. Factors are numbers that go into another number. So turn to page 88. Look at the first section. They give you this number, 2,385. Okay. Then it asks, is this divisible by 2, 3, 4, 5, 6, 9, or 10? We didn't talk about 10, but what does it have to end with if it's divisible by 10?
Ooh.
Abby?
0.
A 0, right. If it ends in 0, we know it's divisible by 10. Okay? So, is this number divisible by 2? You're shaking your head no, Hillary. Why? Because it ends in a 5. It ends in an odd number. So write no. How would we check 3? Is this divisible by 3? What would we do? Andreas? What would we do? What's the rule? You know what the rule is? Look back in your notes if you forgot. One thing that you should always do is to add the digits.
Yes, it is. It is divisible.
Okay? Add the digits. Ethne, is it divisible by 3? Yeah, what's the sum of the digits?
18.
Yeah, 2 plus 3 is 5. Plus 8 is 13, plus 5 is 18. So add the digits. Is 18 divisible by 3?
Yeah.
Yes. What else do we know now? By adding the digits, what else did we find? What other rule says add the digits? What other rule says add the digits? 3 and or, come on, 2 people now? 3 and or, what? Matt?
2 or
No. Abby?
9.
9. 3 or 9. And for 8, you don't add the digits. You don't add the digits for 8. You check the last 3 digits. Okay? So, is this divisible by 9, Trevor?
Yes.
Yeah, because 18 is divisible by 9. Okay? Now, we also know 6. Because 2 and 3, if we know what 2 and 3 are, then we know 6. Is it divisible by 6? Josh? What's the rule for 6? No. What's the rule for 6? 2 and 3. Since it's not divisible by 2, it's not divisible by 6. So it has to be, both of these have to be yeses. If it's divisible by 2 and by 3, then it's divisible by 6.
And it says only even.
Okay? Right, and only even numbers. Alright? Then, is it divisible by 4? What do we have to look at?
No.
Look at what for 4?
Last 2 digits.
Last 2 digits are 85. Is that divisible by 4?
No.
No. Is it divisible by 5?
No.
Yes, it ends in a 5. Is it divisible by 10? No. Alright, so that's what you're going to practice in
It is
this lesson.
divisible by 8.
It's Divisible by 8. 385. 5 and 5, 8.
Oh, wait, I did it wrong.
8 goes into 38
Never mind.
4 times. 4 times 8 is 32. Remainder 6. Bring down the 5.
I did it wrong.
8, 64. Nope, remainder 1.
I did it wrong as well.
Okay.
Because I thought it was like you add 3, 18, and 5, which is 16. So,
Oh, you don't add the digits for 8.
oh,
Yeah. Oh, and I forgot to write 8 up there. No, now what I want you to do is 9 through 20. Okay? Do 9 through 20.